One of the main topics of discussion in the world today is energy, otherwise known as work or power. Now, the big question with energy is how do we get more of it and spend less money at the same time? Energy is all around you, whether it is the energy needed to power your car or the energy needed to power on all your lights, the electrical energy. Now, a lot of this electrical energy comes from power plants, and a lot of power plants use what is known as the Rankine cycle to generate this power. The Rankine cycle, which is what we'll talk about in a couple seconds, is one that incorporates multiple different steps that have all kinds of different functions and come together to generate this overall power usage that the world depends on. The Rankine cycle consists of 4 different steps, or parts, if you will. The first is the boiler, and that is followed by the turbine as the second step. The third step is the condenser, and the last and fourth step is the pump. I'm going to talk about the first step, which is the boiler. It does exactly what it sounds like it would do. It boils the water or whatever other liquid may be in the cycle. It turns it from a liquid into a gas, and this part of the Rankine cycle is the main one where you need to input heat into the system. This is usually done by the burning of fossil fuels or the combustion of other chemicals. This is really where you put your money into the Rankine cycle. This is where it costs the most. Burning these fuels, you need to be able to create heat, and that heat goes into the boiler, which then boils the water and provides the steam. This steam, when it exits the boiler, will go into the second step, which is the turbine, and Chris will talk to you about the turbine.
The second stage of the Rankine cycle is the turbine. It comes after the boiler, in which the boiler heats up the liquid, turns into steam. That steam is going to then pass into the turbine and create energy. A way to think about it is to think of a ceiling fan or any fan. You have to turn it on, give it electricity. It spins a fan, which can be a turbine. A turbine is a fan. So the electricity turns on, it turns a motor, and it spins the turbine. What the Rankine cycle does is it kind of does the reverse. You're spinning the turbine or the fan to create energy. The steam will move past the turbine blades, pushing it because the heated vapor is moving fast, it's hot. It's kind of like if you boil a pot of water, steam will move. That's what the Rankine cycle utilizes. Kind of like a reverse fan motion to create energy with a fast-moving vapor.
The third stage in the Rankine cycle is the compressor. Now, a compressor comes from the term compression, which has to do with taking something that has a very large volume and changing it into something that has a very small volume. Now, these changes happen most often with gases and liquids, but a good way to think about it is just taking a piece of paper and crumpling it up into a little ball. You compress that piece of paper. Now, what happens in the Rankine cycle with compression, the steam that exits the turbine goes into the compressor. Once in the compressor, that steam is cooled and it then compresses back into liquid water. So the steam is a gas and it compresses into a liquid so that it can be again cycled through the rest of the Rankine cycle.
The pump is the part of the cycle in between the condenser and the boiler that keeps everything in the system moving. Most importantly, the pump pushes the liquid in the system through the cycle. The pump also changes the liquid that comes from the condenser into a form that can be more easily used by the boiler. Unfortunately, for the pump to push and change the liquid, it requires some energy input. This energy input is a negative impact on how much work the cycle produces. Therefore, it is the job of designers to reduce how much energy is needed by the pump to perform these functions.